talking about reversible reactions, and the term equilibrium appears in the reversible reaction when you have two ways for the chemical reaction.
In other reactions, though, like this one here, we have a double arrow, which tells us that the reaction is reversible. The top arrow tells us that ammonium chloride can break down into ammonia and hydrogen chloride, which we call the forward reaction. While the bottom arrow tells us that the ammonia and hydrogen chloride can also combine to reform the ammonium chloride, which we call the backward reaction. So because both of these can happen, we call it a reversible reaction.
So just to refresh your mind, we will not play it all. We have reversible reaction and forward direction and backward direction for the reaction. If the rate of chemical forward direction is equal to the rate of backward direction, they have the same speed. We call it the reaction is at equilibrium. The equilibrium could be positioned in the middle or to the left or to the right, depending on the conditions of the equilibrium. That's our lesson today. How can we affect the position of equilibrium, and what are factors that affect this equilibrium? So let's go to our lesson today, Le Chatelet principle, which is talking about, we are going to talk about the factors that will affect the equilibrium of chemical reaction.
In this video, we're going to cover Le Chatelier's principle, which is about the position of equilibrium during a reversible reaction, and specifically how it's affected by temperature, pressure, and concentration.
So these are the factors that we are going to discuss, how they will affect the equilibrium point in reversible chemical reaction: temperature, pressure, concentration. I think that we talked about temperature in the previous video. Well, let's explain it yesterday. Today we'll talk about again temperature and pressure and concentration.
We saw in the last video that the position of equilibrium refers to how many reactant particles there are compared to how many product particles there are when at equilibrium. For example, we would say that the equilibrium lies to the left if there are more reactants.
So we talk about the position of equilibrium, and we said if we have the amount of reactants is more than the amount of product, this means that the equilibrium lies to the left. If we have the opposite, if the amount of product greater than the amount of reactants, we would say that the equilibrium lies to the right.
And to the right if there are more products. Now, Le Chatelier's principle is the idea that if you change the conditions of a reversible reaction, then the position of equilibrium will shift to try and counteract that change.
So we will make a change to the conditions of the chemical reaction, and according to this change, the position of equilibrium will change. Let's see that.
And so we can use this principle to predict what will happen when we change the conditions. To see what this means in practice, let's take a look at this reaction for the production of ammonia from nitrogen and hydrogen.
So this is synthesis reaction that will produce ammonia from its component, which is nitrogen and hydrogen. The forward direction says that we can form ammonia from hydrogen and hydrogen. 3 molecules of hydrogen plus 1 molecule of nitrogen will produce 2 molecules of ammonia. The reversible reaction or backward direction of the reaction says that ammonia will dissociate into its component, nitrogen and hydrogen again. The forward reaction, if we put here negative 992 kilojoule per mole, this means for each mole that is formed here, we have consumed negative 92 kilojoule per mole. So this reaction will what? Will consume energy. Let's see that.
And imagine that it was being done within a sealed system.
Again, we said yesterday that the reaction must be to apply Le Chatelet or to have equilibrium point. We must apply or we must conduct this chemical reaction in sealed system, closed system. So none of the reactant or product will escape from the medium of reaction. Okay. So to apply Le Chatelet principle or apply or find the equilibrium point, all of the reactant and the product can't escape, must not escape from the medium of the reaction. That's why we have to conduct the chemical reaction into a closed system or sealed system, because we are studying equilibrium.
The minus 92 kilojoules per mole is the overall energy change of the forward reaction.
So if it's minus, this means the reaction is endothermic. It consumes energy. It absorbs energy. So this is the overall change in the energy of the chemical reaction. It consumes energy. When we form N2 and H2O, we need energy to form NH3. It will consume energy. It needs to be heated to have energy.
And because it's negative, we can tell that the forward reaction is exothermic, which means it releases energy to the surroundings.
This releases
And
the
because the
opposite one.
backward reaction,
The opposite one is endothermic. So both of them happens at the same time. Forward exothermic, backward is endothermic.
has to be the opposite of the forward reaction. It must be endothermic. For the sake of our example, let's imagine that the position of equilibrium starts off here in the middle. If we were to...
Again, minus means the reaction what exothermic. If we put minus here, this means it releases energy to the surrounding. So this is the forward reaction. And if we go to the backward, it must be of the exothermic. This would be endothermic. So if we do this reaction, decrease the temperature by doing this reaction in a ice bath, okay, what will happen? We will take this energy out of the system. So the energy or the reaction will be active in the direction that will reverse that change. That's it. Will shift to try and contract what? The change. It will try to resist the change. If we are consuming energy here, so the reaction will try to reverse our change, the change that we made it. We are consuming energy, we take it out here by ice, because ice will consume this energy released from the exothermic reaction. Another reaction will be active in the direction that releases more energy. Okay, the reaction will go in the direction that will produces more energy to reverse our change. Our change is what? Consuming energy, taking energy. The energy is released from the forward reaction. We will take energy out, okay, by ice. This energy will make ice melt. So we are consuming energy that is released from forward reaction. So what happened? The reaction will respond to that by trying to eradicate or opposite our change, okay? Shift to try to contradict our change. What direction here, forward or backward, will make the opposite of consuming energy. We consumed energy, it will release energy. If we consume, it will give us more energy. So it will be active in the forward direction. Let's see how we say it.
Decrease the temperature of our system. The equilibrium would move in the exothermic direction in order to release heat energy and counteract that change that we just made. In this case, that would mean the position of equilibrium moves to the right. So
again, Le Chatelet principle say the reaction will try to shift to counteract the change we have made, to make the opposite, to try to balance the change we have made. If this reaction exothermic releases heat to the surrounding, we put this reaction into ice bath. The ice bath will consume energy released from exothermic. So the reaction will think, I want to reverse the change that happened to me. They are using my energy, so I have to add more energy. He's doing the opposite. He's doing what? The opposite of the change we have made. The change we have made, we taken energy out of the system. We take this energy out of the system. This releases energy, the exothermic or the forward reaction releases energy, and we consume this energy. So the reaction will be active in the direction that reverse or counteract the change we have made, which is the forward direction, to release more energy, to replace that we have consumed from the medium.
It would have more ammonia particles and fewer nitrogen and hydrogen particles.
According to this reaction, the reaction shift will be shifted to the right, and this means it will produce more of ammonia gas and fewer of nitrogen and hydrogen gas. So that's the meaning, and that is the effect of the chemical reaction. If we want to produce more ammonia gas, we will do this experiment in ice bath. So we will take the energy released from the exothermic forward reaction, and then the reaction will respond to that by moving or being active in the forward direction to replace the energy that we are using, that we have taken out from the system. So it will be active in the forward direction, and this will give us more of what? More of ammonia gas, because the balance position will be shifted toward the right, and this means it will release more of ammonia gas and fewer of nitrogen and hydrogen.
On the other hand, if we increase the temperature of our system, Then
Now, if we, in the same reaction, if we increase the energy, heat in the system, what will happen? Increase temperature, the energy, this is a change. Again, you start with a change. We made it as humans, as scientists or as students. You make a change to the reaction. The reaction again happens in the sealed system, and you are changing circumstances, conditions. We talked about doing the reaction or putting the medium of the reaction or the flask where the reaction happens into ice bath. Right now, I'm going to heat the flask. What would happen? The reaction will feel the change that I have made, and it will move in the direction that counteract or try to opposite my change. Which one will opposite my change? My change is that adding heat energy. So which one will contradict or counteract my change? Endothermic or exothermic? Anybody can answer?
Can you repeat the question, mister?
I'll say the question again. Right now, I make a change by heating. I increase temperature. The reaction will respond in a way that counteracts my change. Okay, so which direction will counteract my change? Exothermic or endothermic direction? Again, I heat it up. So the reaction have to make the opposite. Okay, have to counteract my change. So you have two directions. You have exothermic, this direction added more energy, adds more heat, and endothermic consuming heat. So what direction of this, what is the direction that will contradict or counteract the heat that I'm adding, the increasing of temperature that I'm applying right now to the system?
Exothermic, mister.
Exothermic will add more heat. You are not doing the opposite of my change. You are doing the same change. If the reaction be active or activate itself in the direction of exothermic forward, it will add more heat, like the heat I'm adding right now. So you are not contradicting the change I made. Again, the main idea that the reaction will go in the direction that counteract the change that I'm making. Exothermic will not counteract. Exothermic will add more energy. Exothermic will add more energy. Energy is released. Okay, so we'll add more energy to the medium. We don't need that. We need to counteract adding more energy. So it's not sure for exothermic. What is it? What is it, guys?
It's endothermic.
Yes, endothermic will consume energy. So when we heat the reaction, increase the temperature, the reaction will be shifted toward the endothermic reaction to counteract the change I'm making, which is increasing heat, increasing temperature. Okay? So the reaction will be shifted toward the left. And this means fewer of ammonia gas and more of nitrogen and hydrogen gas. Let's listen.
to oppose this change and decrease the temperature, the equilibrium will move in the endothermic direction, so to the left, which means we'd have more nitrogen and hydrogen, but fewer particles of ammonia.
So I'll ask
can
you a
also-
question here. If we are in a factory to produce ammonia gas, what do you expect to conduct to make the reaction medium, to put the reaction medium in hot temperature, increase the temperature, or put it into a cold medium? Which one is better for producing moon ammonia gas? I want your answer, guys.
Mister, your voice was lagging. Can you repeat?
I'll say it again. If we are in a factory, a plant for producing ammonia gas, and we want to increase the production of ammonia gas, we will conduct this reaction in cold medium or hot medium.
Hot medium.
Cold, mister.
Okay, we have two different ideas. Type in the chat area if it's hot or cold medium. Type in the chat area, guys. I want to increase ammonia production. We have this reaction in a factory, and I want to increase ammonia production. I will conduct this reaction in cold weather or hot. Cold, Muammal cold. Muaz didn't answer yet. Okay, Muaz cold. Abdullah Dahilan, low temperature cold. Muhammad, because heat decreases the amount of ammonia. Not, this is not the right. Yes, it's cold. Yes, I like your answer, cold, but no, this is not the explanation, Muhammad. Explanation is here. We said the explanation. Someone raises his hand. Who's raising his hand? Muaz, what don't say, Muaz?
It is hot, but after I thought, because if it was hot, it would be released. So yeah, it is cold.
Yes. Again, the reaction will be activated, will active in the direction that counteract my change. My change, if I put in cold bath, okay, in a cold medium, this cold medium will take this energy out, will take energy from the system. So I want to increase more energy. I want to add more energy. So which direction will add more energy? Exothermic or endothermic? Which one will add more energy? Exothermic or add endothermic? I'm taking energy from the system. So I will be active in the direction that add more energy, which is exothermic. Again, exothermic add more energy to the medium. Endothermic consume energy. So exothermic will release energy here. If I'm taking by ice, taking energy out of the system, so the reaction have to be activated in the direction of exothermic reaction forward. To do what? To compensate the energy that I'm using out or taken out from the system. So the reaction will be activated in the exothermic reaction. And if this happens, it will produce more ammonia gas and less of nitrogen will be there in the reaction. So if I'm in a plant or a factory to produce ammonia, it's better to conduct this reaction in a cold temperature because the reaction will be shifted toward the left in the forward direction, toward the right in the forward direction, which will produce more ammonia gas. So the summary for this, if I want to increase ammonia gas production, I have to conduct this experiment or this reaction in a cold medium, Okay. It need to be absorbed low temperature, cold. I don't know. It's a cold, yes, but I don't understand what is the first part you are saying, Abdullah Dahilan. Okay, let's continue with listening here. We'll finish that.
Of ammonia. We can also apply this concept to the pressure of our sealed system. So if we increased the pressure, then the equilibrium would move to whichever side reduces the pressure back down.
So we finished talking about temperature. To understand temperature, you have to know which one is exothermic, which direction exothermic, and which direction is endothermic. Okay, to understand the effect of cooling and heating the reaction. Right now we'll talk about the pressure. So to count the pressure or to know the pressure, you have to count moles. How many moles do we have here in the left side? Someone answer me. How many moles do we have here? Total moles. How many moles here and how many moles here?
6 into 8.
No. Moles, not atoms. Again, the number here is number of moles. We have 3 moles of hydrogen and how many moles of nitrogen?
1.
1. So the total moles for reactant is 4 moles. And how many moles for nitrogen here, for ammonia here? How many moles? Only this number of moles. 2. So the pressure to the left is greater than the pressure to the right. We know this by comparing the number of moles in each side. The side that has more moles has more pressure. So if we look here, we have 4 moles to the left in the reactant side and 2 moles to the right. So the pressure to the left is greater than the pressure to the right. So if we increase the pressure of the medium, this reaction, we conduct this reaction under high pressure. The reaction will be active in the direction that reverse or counteract my change. So we have forward, will move from 4 moles to 1 moles, and the backward will move from 2 moles to toward the 4 moles. If I increase pressure, the reaction will activate itself in the direction that decrease pressure. If I want to decrease pressure, I go forward or I go backward, guys. Let me take this as a screenshot. Just one minute. so I can explain it to you. Okay. Let's set this. Angular motion controls. Now let's add this one here, and let me show you. We have here 1 mole, we didn't write 1 mole, we have 1 here and we have 3 here. So the number of moles are in this left side are 4 moles. Okay. And in this side we have only this number here is 2, so we have 2 moles. Okay. So if we conduct this reaction under high pressure, increased pressure, as you see right now, there is a movement that decrease pressure. If I increase pressure, the reaction must go in the direction that decreases pressure. It must contradict or counteract my action. If I increase pressure, it must go in the direction that decrease pressure. We have 2 ways here. We have forward here and backward. If I go forward, I will move from 4 moles to 1 mole. So I am decreasing pressure. If I go from the backward direction, I'll go from 2 moles toward 4 moles. And this backward, it increases pressure. So if I increase myself from outside on the system itself, I increase pressure. The reaction must go here in the direction that decrease pressure. So that will be number 1 or number 2, guys. Number 1 or number 2?
2.
Again, if I go so backward, I will move from 2 moles. هتحرك من 2 مول ل4. من 2 ل4.
1 mister.
So I'm increasing pressure. So in 2, I'm increasing pressure. If the reaction activates itself in one direction, number 1, in the forward direction, it will decrease pressure. So the reaction will not go in 2 directions. It will go in what? In 1 direction. In this direction, it will move from 4 moles toward 2 moles, which mean decreasing from higher to lower number of moles or number of particles, number of gas particles. So if the reaction activates itself in the forward direction, it will decrease pressure. It will move from higher moles to lower moles, and by this way, he is counteract the changes they have made, which is increasing temperature. Which is increasing what? Temperature. So this is how the reaction responds. It counteracts the change I made. It counteracts the change I made. Let's erase it again, all again. So we start with something change, we made it. The change we made it with increased reaction. That's it. The reaction will understand what are you doing. You increase reaction. So I have to decrease this change. I have to go in opposite direction. What direction would decrease pressure? We have increased. So the reaction must go in direction that decreases pressure, which is forward direction. Which is what? Forward direction. This forward direction, it will move from higher number of moles or greater number of moles, from 4 moles to lower number of particles or moles, which is 2 moles. That means you are doing what? You are decreasing pressure. So if you go in the forward reaction, the reaction would decrease pressure, and the Le Chatelier principle is applied. This applies in temperature, this applies in even concentration, as we will see after this one. In all of them, the reaction goes in the direction that counteract the change that have been made on the reaction itself. So let's listen to the video again.
And as pressure is basically just a measure of how many particles there are per unit of volume, to lower the pressure, the equilibrium will move to the side with the least number of molecules, which in this case is the right, because there are only 2 molecules of ammonia on the right-hand side, whereas there's 4 molecules left, because there's one
Number of molecules or lower moles, okay? Because this direction will decrease the pressure, and this will counteract the change that we have made, which is increasing the pressure.
plus 3 hydrogens. On the other hand, if we decrease the pressure, then the equilibrium will shift to the side of the more molecules. So
The opposite one. If we decrease temperature, if we decrease the let me take it. If we decrease pressure, what would happen? Let's see it. Now we decrease the pressure. As you see here, we decrease the pressure. This is our change. I make it in red. We decrease pressure. So the reaction must counteract what we have made. So the reaction must increase pressure. That's what he have to do. He must increase pressure. To do that, he will move in direction number 1, forward direction, or direction number 2, guys. What direction will increase will increase pressure? We want to increase pressure. Who can answer me? شباب يا قوم.
No, Mr. My phone.
I'm asking. Now we decrease the pressure. We decrease the pressure. Okay. So the reaction will activate itself in the direction number 1 forward or direction number 2 backward. Remember that he wants to increase pressure to counteract the change that we have made. So which one will give us, which direction will increase the pressure? Direction number 1 or direction number 2?
2.
Yes, direction number 2. Direction number what? Number 2, because it will move toward more molecules or more moles. So this is the direction that increases pressure. So in case number 1, if we increase the pressure, we will have more ammonia gas. If you see that. We said in this reaction, we have to make it in a cold medium. We increase ammonia gas. Also, the plant will make it under high pressure because high pressure will produce more of ammonia gas. So this is the optimum condition to produce ammonia gas. Number 1, increasing the pressure. This is number 2. And number 1, conduct the experiment in a cold medium, or ice bath. Okay, these are 2 conditions to increase the amount of ammonia gas produced, that is produced. Let's continue listening.
to the left in order to increase the pressure again. The very last change that we need to look at is changes in concentration.
And change in concentration means that you will take some of ammonia gas produced, take it out away from the medium, consume it, take it away in bottles away from the medium, extract it from the medium. This means you are lowering the concentration of ammonia gas. And if you do that, the concentration will go in the direction that add more ammonia gas. The concentration is so easy. If you take someone, the reaction will activate in the direction that will compensate what you have taken from the medium. So if you took ammonia gas away from the medium, the reaction will go in the forward direction. That will add more ammonia gas. If I take nitrogen out of the medium, the reaction will go in the direction that add more nitrogen gas, which is backward direction, and so on. So concentration is the easiest one in all 3 factors that affect the equilibrium of chemical reaction.
For example, if we added more nitrogen to our sealed container.
Now I'm not taking nitrogen, I'm adding more nitrogen. So I'm increasing the concentration of nitrogen. The reaction will move in the direction that will counteract this change, which is forward reaction that consumes nitrogen. So if I increase the concentration of nitrogen, the reaction will go in the forward direction, which is the direction that decreases the concentration of nitrogen gas.
It would increase the concentration of nitrogen. So to oppose this change, the equilibrium shifts to the opposite side, which in this case is the right, and forms more ammonia. And that's it for this video. So if you found it helpful,
So thank you guys for listening. Right now, I'm going to give you a quiz on Le Chatelet principle, pressure, temperature, pressure, and concentration. We will continue with this lesson in the next session too. So we wouldn't read it yet. So we'll continue to read this question, this lesson in the next session, inshallah, and have more examples on it. But right now, let me
Does
give you
this
a
mean
quiz.
we can leave now?
No, you are not leaving. I give you a quiz. I don't say it if you have to leave. We'll take quiz on factors affecting chemical equilibrium. Okay, factors affecting us, chemical equilibrium. Okay, this is good. So join the link, guys, and join the quiz. I sent the link and the pen too. We have 23 students. I want all of you to join, guys. All of you to join, please. I will start quickly because we don't have much time. So we have only 4. I want all of you to join, guys. Quickly join. I will call for absence right now. Physical science.
Muhammad Al Abdul Baqi is not absent.
Okay, that's good. And first one, Abbas is here. عبد المجيد فرهودة. عبد الهادي.
هير مستر عبد المجيد هير.
Okay, he was absent in the previous session. Abbas, absent. عبد الهادي.
هير.
Okay, here. عبد الله حسين عبد الباقي.
هير.
Okay, عبد الله عبد اللطيف. عبد الله عبد اللطيف. عبد الله دحيلان. Okay, عبد الله.
كثير مستر كثير عبد الله السلام.
عبد الله المبارك. عبد الله المبارك. عبد الله المبارك is here. عبد الله عبد اللطيف here, but عبد الله المبارك didn't answer me. عبد الرحيم عادل. أدهم.
Yes, mister.
Okay. أحمد متعب القناص.
Yes, here.
علي، لا مش عارف هو. علي يوسف الهلال. علي يوسف الهلال. علي يوسف الهلال. فيصل. حسن.
Yes, Mr. Faisal is here.
Okay.
Yes, Hassan is here.
إبراهيم مبارك. إبراهيم عادل.
Yes, here.
إبراهيم أنور is here. إبراهيم الربيعة.
Here.
إبراهيم. Okay. معاذ.
Oh, I'm here.
Yes, here.
Okay.
I'm
مؤمل.
here, Brian.
عند إيه سنة إبراهيم. مؤمل.
Yeah.
محمد عبد الباقي زهير. محمد أيمن.
I'm here, mister.
Okay, محمد.
محمد العبد القادر is not here, mister.
I know. محمد رمضان. محمد رمضان.
Yes, mister, I'm here.
محمد فضل. محمد فضل.
Yes, I'm here, mister.
مرتضى. اوكي. مرتضى.
Yes, mister.
نفجان. نفجان. أسامة. أسامة فراس. سعد محمد اليوم. يس.
عباس رمضان is here.
وانت كنت فين يا عباس؟ Where have you been?
I was late.
طيب يا عباس. اوكي. And last سعد اليامي is here.
I'm here, mister.
سعد الحسيني. سعد الحسيني. علي كمال المرزوق. علي كمال حسين. علي كمال حسين المرزوق.
I'm here.
اوكي علي. So علي كمال حسين. سعد خالد الحسيني سوري سعد خالد الحسيني absent. أسامة absent. نفجان absent. علي يوسف الهلال absent. عبد الرحيم عادل absent. عبد الله محمد المبارك absent. Okay, I called the absent people. So let's see your answer. Okay, guys. You can repeat the quiz again if you want to improve your marks. You can repeat it again if you wish. We have only 12 players, 12 students join the quiz. Where are the rest of you guys? Let me take out the absence people. Let's see how many one is here. We have only 12 players, while we have here in the session 22 students. And it says 23. And we have 17 right now in the session. Okay, guys, we have come to an end of our session today. I'll see you inshallah tomorrow. And don't forget the project, guys. Don't forget the project. Don't forget the project. Okay, guys?
Mr. What?
Go to the Classera. You will find the video. I have uploaded it yesterday by the title projects. Listen to it and figure out what is the project, okay? Okay, guys?
Okay, thank you.
Okay, thank you, guys. Bye-bye.
Thank you, teacher.
Thank you. All right, thank you very much.
Thank you, mister. Have a nice day.